Good day, everyone. Today we are going to discuss another way in solving for the solution of a differential equation. So basically, we already discussed all about the other ways in order to solve for the differential equation. We had elimination of arbitrary constants. We also have separation of variables. We also did linear first order differential equation, and we actually move on to discussing all about the application for differential equation. Some of those because they can be solved uh, using separable. So now we are going to continue with ways we are going to solve for the differential equation, and one of those is the Bernoulli form. And it's actually quite easy because it's just an extension with the linear first order differential equation. So to give you a background or an idea what I'm talking about, why is it just an extension of the first linear first order differential equation and how we solve for those equations or solutions. Um, the Bernoulli differential equation was proposed by Jacob Bernoulli. So basically, this is Jacob Bernoulli. He was the one that formulated the Bernoulli equation or the Bernoulli form in 1695 in the journal Acta Eruditum. So this was the Acta Eruditum where they published the work or where he had the published the work all about Bernoulli differential equation. And with the problem solving it being one he had grateful with 4 months and decided to put out as a competition. The equation, which bears Jacob Bernoulli's name due to his formulation of it, has a distinct form of y prime plus p of x of y is equal to q of x y raised to n. As you can see, sa linear first order differential equation, we also have to come up with a form of the linear first order differential equation and then follow the steps of solving for the solution. It's basically the same thing as what we are going to do with the Bernoulli equation. But they have differences. So as you can see in the form of the Bernoulli equation, it is in the form of y prime plus p of x of y is equal to q of x y raised to n. So yung sa linear first order, we only have y prime plus p of x of y is equal to q of x. So basically, wala tayong y raised to n. So if you try to solve for a linear first order and then you have found out when you are trying to come up with a linear first order form, and then you have this, then it's not solvable using that because you have not taken into consideration that term. So if that's the case, then that you arrive to that form, you have to make use of the steps in order in the Bernoulli equation in order to come up with a general solution. And then also another thing with these form, the one who had found out for the solution of these form was Gottfried Leibniz. So you already all about know about Gottfried because they were the one who founded uh, calculus with Newton. So Gottfried Leibniz published the first solution to the equation. The equation is a nonlinear first order or order ordinary differential equation that can be transformed into a linear equation by a substitution, a method still used today. So this is the method that we are talking about in order for us to calculate for the general solution of the differential equation. So this is the method. Yung first step is, of course, at the same case with the linear first order, we have to arrive to the Bernoulli form. So the Bernoulli form again is this one. And then the next step, just like what we did in linear first order, we have to identify the values or the terms that we need in order to come up with a general solution. And again, there are two cases that we could, or there are two things that we could calculate or arrive for a solution. We have the general solution and the particular solution, and I know you know the differences between the two. In particular solution, of course, it has to have initial conditions, which would be this particular solution is part of the family of solutions, which is what you call the general solution of the differential equation. So we need again to identify the p of x, the q of x, and then an extra for that one is the n. So yung n na lang yung hanapin mo as well. And then there is also difference between the integrating factor that we need to use in the general solution. So yung sa integrating factor for the linear first order, we only have e integral p of x dx. But for the integrating factor of the Bernoulli equation, it has 1 minus n. So it would be now I of x is equal to e integral of 1 minus n p of x dx. And for the general solution, of course, my differences as well. We have the general solution formula now would be y raised to 1 minus n is equal to 1 over I of x. The quantity of integral of 1 minus n times q of x times I of x dx plus c. So in order to show you how we calculate or how we come up with the general solution of these type of equation or Bernoulli equation, I have an example given on the file that I already uploaded actually on the GC. Example 1. So, may dala dito example. Let me just discuss how it is being calculated. So, for number 1, you have to solve for the following differential equation. So, the differential equation is xy prime is equal to 2x squared over y plus 3y over 2. So we have to follow the steps that I introduced in order to come up with the general solution. So to do that, of course, the first thing that you need to do, if it's not in the form of the linear first order or in the Bernoulli form, we have to algebraically manipulate the equation to arrive to that form. So again, the form that we want to arrive is y prime plus p of x y is equal to q of x y raised to n. So the best way to do that, if I'm going to solve the problem, is I'm going to divide both sides by x so that I could just isolate y prime first. So xy prime for step 1 is equal to 2x squared over y plus 3y over 2. I'm going to divide both sides by x. So it would let me cancel the x and isolate only y prime. So y prime would now be equal to 2x squared over y plus 3y over 2 divided by x. And then it can also be represented as 2x squared over y times 1 over x plus 3y over 2 times 1 over x. And then as you can see, we could actually cancel this out. Now we would be just left with y prime is equal to 2x over y plus 3y over 2x. Now we have to identify which is our p of x, which is our q of x. So for this case, it's much better if we assign our what do you call this one, 3y over 2x is our p of x. As you can see, y should be y should be the only left, should only be the value here. So obviously that would be our p of x. So it would be now y prime, transpose this one to the other side of the equation. It would be now y prime minus 3y over 2x is equal to 2x over y. And then y prime minus 3 over 2x of y. As you can see, it is now in the form of p of x, y. And then equal to 2x. As you can see, kailangan nasa numerator yung ating y. To do that, we use law of exponents. We transfer our y to the numerator. And then, of course, yung exponent would change. So it would be now 2x y raised to negative 1. As you can see, we arrive already to the form. We proceed with step 2. Step 2, as you can see, is to identify the values that we need. So the values that we need is p of x, q of x, and our n. So which is our p of x? Of course, we have already identified that one while we are transforming the equation. So yung p of x natin is 3 over 2x. And then our q of x there is 2x. And our n is equal to negative 1. And then for step 3, we calculate for the integrating factor. The integrating factor is being used again for the general solution. And the integrating factor for Bernoulli equation is I of x um, equal to e integral of 1 minus n p of x dx. As you can see, magagamitan na naton p of x and then our n. So it would be now equal to e integral of 1 minus negative 1 p of x is 3 over 2x dx. And then we simplify. It will now equal to e integral of 1 minus negative 1 is 2, and then 3 times 3 over 2x dx. And then this can still be simplified, so it would be now equal to e integral of 3 over x dx. And then we just do integration. So you are going to make use now of what you learned in integrals. So integral of 3 over x dx, we could actually factor out 3. Integral of dx over x. And then integral of dx over x is just ln x. So therefore, 3 ln x. And then it would be now equal to e 3 ln x. And also a thing with laws of natural logarithm is that for these cases na 3 ln x, we could actually set our 3 here as an exponent to your x. So it will be now e ln x raised to 3. And then another thing with exponentiation is that we could actually take only x raised to 3 if we have e ln x. So e ln x is just x, so therefore applying that rule, we only take x raised to 3. So therefore our integrating factor is going to be just x raised to 3. And then we are going to move on to our step 4. Step 4 is now finding for the general solution of the differential equation. And we have a formula for that. The formula is y raised to 1 minus n is equal to 1 over I of x times integral of 1 minus n q of x times I of x dx plus c. So yan. So ganyan. I think it's much better if this is if I could further define yung ating formula. Ganyan. So that we do not get confused. So yan. Ganyan dapat yung formula. Kasi later on, you would see that it would have an effect with our arbitrary constant. We don't need to have an effect with the arbitrary constant yet. The arbitrary constant would be now multiplied with the I of x later on. So that would be the formula. And then again, we need those values that we identified. So yung p of x again a while ago is 3 over 2x. And then, yung sa q of x natin, it's actually 2x. So, is that correct? Yeah. So, yan. Anyways, also, another thing pala na ginawa ko sa aking form, dapat positive to. So, it has to be negative here. So, let us just correct ourselves, no? So, negative dapat to. So, dapat negative draw. So, dapat negative tong lahat. So, kailangan positive. Kung positive yung equation natin, kailangan we take into consideration also the signs. So, it has to be negative here because the standard form is positive. So, it would be now, ganyan. So, dapat negative tong lahat. So, yan. But anyways, that's just a minimal correction to the solution. So, kailangan negative din to. We set up negative for our p of x. And then, the next thing that we would do We forgot about the n, negative 1. So it would be now substituting those values. So y raised to 1 minus negative 1 is equal to 1 over I of x. So I of x a while ago is x raised to negative 3. So this would be x raised to negative 3 times the quantity of the integral of 1 minus negative 1, and then the q of x, which is 2x, and then the I of x is x raised to negative 3 dx plus c. And then y raised to 1 minus negative 1 is 2, and then 1 over x raised to negative 3. We could actually just transpose this one to the numerator, so it would be now x raised to 3, and then this one will be the integral of 2 times 2x times x raised to negative 3 dx plus c. And then this would be now y squared is equal to x cubed times the integral of 4x times x raised to negative 3 dx plus c. And then this would be now y squared again, x cubed is equal to x cubed, and then times the integral of 4. This one, x times x raised to negative 3 is basically 1 plus negative 3 for the exponent, so it would be now x raised to negative 2 dx plus c. And then it would be now y squared is equal to x cubed, and then we could actually get the value for the integral of 4x raised to negative 2 dx, which is, we just factor out 4, and then in the integral of x raised to negative 2 dx is just 4 times x raised to negative 2 plus 1 over negative 2 plus 1. So we would have 4 times x raised to negative 1 over negative 1, which is now negative 4 over x. So negative 4 over x tayo dito, plus c. So yan. And then y squared is equal to x cubed times negative 4x. That's basically just negative 4x cubed over x. And then this one would be also distributed, so 6x raised to 3. And then that is equal to y squared is equal to negative 4x squared plus cx raised to 3. Pwede pa natin what do you call this one? Arrange. So it would be prettier for the equation, no? So we could have this as y squared is equal to 6x raised to 3 plus no, minus 4x squared. Or you could actually write this one as 4x squared. Pwede hapon 4x squared plus y squared is equal to cx raised to 3. Either which, because pwede man itong bisan ano hiya nga arrangement, as long as the signs are correct and the values are there. So you could have this one, pwede gapadi, pwede gahapon na di. But it's much better if uh, um, it's positive for the first term that we have, unlike this one nga negative siya, so that um, mas maganda siyang tingnan. But wala man kita rule na diri dapat sugaron hiya. So anyways, that's going to be the solution of the differential equation that was given. So we have y squared is equal to 6cx cubed minus 4x squared, or you could have 4x squared plus y squared is equal to cx raised to 3. And then we still have more examples actually done sa file that I gave you. So let's move on to the next example. So the next example is for you to solve the differential equation y prime plus 2 over xy is equal to x cubed y cubed. So Same case, we are going to um, transform the equation into the Bernoulli form by doing algebraic manipulation first, if it is applicable. But for this case, as you can see, it's already of the form y prime plus p of x y is equal to q of x y raised to n. So there is no need for us to transform it into Bernoulli form. What we need to do is just move on to step 2. Identify what we need in order to calculate for the general solution. So for step 2, what is the p of x, what is the q of x, what is the n? So for the p of x, that is 2 over x. The q of x, that is x raised to 3. Our n is 3. And then for step 2, we have step 3, we have to calculate for the integrating factor. And again, we have a formula for that. The integrating factor is I of x is equal to e integral of 1 minus n p of x dx. Substitute whatever value you need. So it will be now equal to e integral of 1 minus 3 times the p of x, which is 2 of x dx, equal to e integral of negative 2 times 2 over x dx. Be now equal to e integral of negative 4x dx. Do integration. Integral of negative 4x dx. We could actually factor out negative 4, so you would have integral of dx over x, which would give you just negative 4 ln x, because the integral of dx over x is ln x. Now, it would be now equal to e negative 4 ln x, and then we could rewrite it as e integral e ln x raised to negative 4. And we could just get x raised to negative 4 by using exponentiation, or using the rule for exponential values. So x raised to negative 4 would be our I of x. And then moving on to step 4. Step 4 is making use of the general solution formula, which is again y raised to 1 minus n is equal to 1 over I of x times the integral of 1 minus n q of x I of x dx um, plus c. And then what it was our n there? N is again 3. So 1 minus 3 is equal to 1 over our I of x, or our integrating factor, which is x raised to negative 4. 1 over x raised to negative 4 times integral of 1 minus 3 times our q of x. Q of x is x raised to 3 times our I of x, which is x raised to negative 4 dx plus c. And then we simplify 1 minus 3. Y raised to 1 minus 3 is negative 2. Y raised to negative 2 equal to 1 over x raised to negative 4. You just rewrite it as x raised to 4 times the integral of 1 minus 3 is negative 2 times x raised to 3 times x raised to negative 4 times dx plus c. And then you would have y raised to negative 2, x raised to 4 times the integral of negative 2 times x raised to 3 times x raised to negative 4. Actually, we could just have integral of negative 2 x raised to negative x raised to 3 times x raised to negative 4 is just 3 plus negative 4 for the exponents. So it would be now x raised to negative 1 dx. So it would be now hmm, dx. So 1 raised to, yeah. So it would be now dx for that, and then plus c, the quantity of that, and then it would be now x raised to 4. Tapos, next thing that you would do is get the integral of this one, integral of negative 2x raised to negative 1 dx, which would be negative 2 integral of dx over x. Integral of dx over x, which is equal to negative 2 ln x. So it would be now negative 2 ln x um, plus c. Right. And then the next thing, y raised to negative 2, and then you just distribute. So it would be now negative 2x raised to 4 times negative 2 ln x plus cx raised to 4. And then next thing that you would do is basically just simplify. So, ini pwede pa ini rewrite. We could just have y raised to negative 2x raised to 4 ln x raised to negative 2, or we could have um, negative 2, hmm, which should be better. Negative 2 x raised to 4 ln x plus cx raised to 4. And then we could have this one is y raised to negative 2 or 1 over y raised to 2 is equal to c x raised to 4 minus 2x raised to 4 ln x. So yan. Actually, it's okay if this is the case, or pwede man gihapon ni Muhiya i-write also as y squared by multiplying y squared on both sides na. O pwede niya nga ato higbaon mo atong y squared. It will be na y squared is equal to um, 1 over cx raised to 4 minus 2x raised to 4 ln x. So yan. Anyways, that will be the solution for um, number 2. And then for number 3, you have to solve for the differential equation y prime plus 3x squared y is equal to 4x squared y squared. So, ano yung gagawin natin for this case naman? So, for this case, what we are going to do is do the same thing. Do the same thing as what we did um, with the other items. So we have to identify again uh, if it is in the Bernoulli form already. So for this case, y prime plus p of x y is equal to q of x y raised to n. So it's in the form of that already. So we just have to identify yung values that we need for step 2. So for step 2, identify p of x. What is the q of x? What is the n? So yung p of x there is 3x squared. The q of x is 4x squared. And then the n is 2. And then we solve for the integrating factor. The integrating factor formula is I of x is equal to e integral of 1 minus n p of x dx. It will be now equal to e integral of 1 minus 2 times our p of x, which is 3x squared dx. And then you simplify, e integral of 1 minus 2 is negative 1. So we would have negative 3x squared dx. And then we calculate for the negative 3x squared dx na value using integration. And then we could just factor out negative 3 times x raised to 3 over 3. So it would be now using power rule. So it would be now cancelled out for this. So you would have negative x raised to uh, 3. So you would have now e raised to negative x raised to 3 as our integrating factor. Now, since we have the integrating factor, we could now calculate for the solution of the differential equation using the formula. So again, the formula is y raised to 1 minus n is equal to 1 over I of x times integral of 1 minus n q of x um, times I of x dx, the quantity of that plus c. And then y, what is our n again? The n again identified was 2. So 1 minus 2 is equal to 1 over the I of x, which is e raised to negative x raised to 3. And then times the quantity of the integral of 1 minus 2 times our q of x, which is 4x squared, times our I of x, which was e raised to negative x raised to 3 dx plus c. And then y, just basically simplify, y raised to negative 1 is equal to 1 e raised to negative x cube, or you could just rewrite this one as e raised to x raised to 3, and then times the integral of negative 1 times 4x squared times e raised to negative x raised to 3 times dx plus c. And then this can be rewritten as 1 over y is equal to e x raised to 3 times the integral of this will be negative 4x squared e raised to negative x raised to 3 dx plus c. And then, as you can see, we need to get the integral of negative 4x squared e raised to negative x cube dx. And then, I hope so that you have been taught about the techniques of integration or either ways in order for us to get the integrals. So for this case, it's much better if we do use substitution, because if we set up u as negative x cubed, we could have or we could arrive for negative x squared dx, and then with that we could use u substitution, or the way in order to find the integral using u substitution. So I would set up u here as negative x cubed, and then if you get the derivative of that, that will be du negative um, x squared, I don't know, negative 3x squared dx using power rule. And then kailangan may ma-substitute hito dida nga aton equation, no? X squared negative x squared dx can be replaced using this one. So I could divide both sides by negative 3. So, I could divide it by 3 so that I can substitute immediately negative x squared dx. So 3. So it would be now negative x squared dx is equal to du over 3. So going back to the original equation, it would be now the integral of um, this one in a negative x squared dx would be now replaced with du over 3 times this one, e. Remember again, you set up negative x cubed as u. So it would be now eu. So you would have this as a new value here, or the new term here, and then you go into the integration process. So it would be now integral of eu du over 3. And then we just factor out 1/3. Integral of eu du is basically equal to 1/3 times eu plus c. We did not take into consideration the arbitrary constant because it's together with this. So um, it would just be 1/3 eu, and then you substitute it back to its original value. So, oh, I forgot about 4, by the way. So my 4 pi to d that because we only replace it by negative x squared dx. So we still have 4 as an excess. So 4 times 1/3 dapat. 4 times 1/3, so it will be now 4/3 EU. So 4/3 e raised to what was the u, negative x raised to 3. So 4/3 e raised to negative x cubed is the integral of negative 4x squared e raised to negative x cubed dx. So it will be now 1 over y is equal to e x raised to 3 times this one, 4/3 e raised to negative x raised to 3 plus c. And then you basically distribute, so it would be now 1 over y. So distribute this one, e raised to x raised to 3. So it will be now e raised to x raised to 3 times 4/3 e raised to negative x raised to 3 plus c times e raised to x raised to 3. And then 1 over y is equal to this one, 4/3 e raised to negative x raised to 3 times e raised to x raised to 3, and then c e raised to x raised to 3. And then this one, no, because we have the law of exponents, it will be now 1 over y is equal to 4/3 in a negative x raised to 3 would be added to x raised to 3, which is going to be 0. E raised to 0 is 1. So 4 over 3 times 1 plus c e raised to x raised to 3. So we would have 1 over y is equal to 4/3 plus c e raised to x raised to 3. And then we could rewrite this one as y is equal to 1 over 4/3 plus c e raised to x raised to 3. We could settle for that. So ito na yung solution ng differential equation na nasa number 3. So yan. And then we still have the last example. Yung last example that I give dun sa file is this one. We have to solve for the differential equation, which is x squared y raised to 4, or the quantity of x squared y raised to 4 minus 1 dx plus x raised to 3y raised to 3 dy is equal to 0. So again, you have to identify if these differential equation can be is in the Bernoulli form already. So for this case, it's not in the Bernoulli form again because we have to have this form, which is y prime plus p of x y is equal to q of x y raised to n. So it's not even near that form. So we have to algebraically manipulate the equation in order to come up with that form. So for me, if I'm going to be the one to solve for this differential equation, I would divide first everything, or the entire equation, by dx so that I could immediately get yung y prime. So for that case, we do step 1, which is we the given, copy the given, and then we divide everything by dx. So basically, the goal is to have the y prime. As you can see, if we do that, you would have dy over dx. So it would be now x squared y raised to 4 minus 1, because this would be cancelled out if I divide each of the term. And then for this case, it will be now plus x raised to 3 y3 dy over dx, or basically dy over dx is just y prime is equal to 0. And then The next thing that I need to do is transpose everything, this one, not everything, but this one on the other side of the equation, so that I could just isolate y prime on the other side or on the left side of the equation. So it would be now x cubed y prime is equal to negative x squared y raised to 4 plus 1, or you could just basically write it as x cubed y raised to 3 y prime is equal to 1 minus x squared y raised to 4. And then I could divide everything, again the entire equation, by x cubed y raised to 3. It would be divided now, it would be now, so the continuation is here, y prime is equal to 1 minus x squared y raised to 4 um, x cubed y cubed. And then I still have to identify which is our p of x and our q of x. So y prime is equal to, I could separate this one. We could do that. So 1 over, this can be rewritten as 1 over x cubed y cubed minus x squared y raised to 4 x cubed y cubed. So y prime, this one can be um, this one, I mean, can still be simplified. So y prime is equal to 1 over x cubed y cubed minus this one, x squared over x raised to 3 is just x. So we're left with x on the denominator, and then y raised to 4 divided by y raised to 3 is y. So y prime is equal to 1 over x cubed y cubed minus y over x. And then what we are going to do now is to identify which is our p of x and q of x. Obviously, our p of x is y over x because it has to be that our y is positive for the exponent. So it would be now y prime. I would transpose this one to the other side. So it would be now y prime plus y over x is equal to 1 over x cubed y cubed. And then y prime plus 1 over x y. And then this one would be 1 over x cubed. And then remember again, we have to identify our y raised to n. So this could be now rewritten as y raised to negative 3. So with that, it's in the Bernoulli form. We could now easily identify what we need. So what we need is, oops, oops, a while. What we need now is our p of x, q of x, and our n. So our p of x obviously is 1 over x. Our q of x is 1 over x raised to 3, and n is negative 3. Now we could calculate for the integrating factor, which is for the formula, that is what I of x is equal to e um, integral of 1 minus n p of x dx. And then we basically substitute those values. So integral of 1 minus negative 3 times the p of x, which is 1 of x dx, and then it will be equal now to integral of 1 minus negative 3 is 4 times 1 over x dx, which is equal to integral of 4 over x dx. So integral of 4 over x dx is, we could factor out 4. We take the integral of dx over x, which is equal to 4 ln x. And then it would be now integral of 4 ln x can be written as ln x raised to 4, which is going to be x raised to 4 for our I of x. And then the last one, the last step is for us to use the formula now, the general solution formula, in order to find for the solution of the differential equation, which is y 1 raised to 1 minus n is equal to 1 over I of x times the integral of 1 minus n q of x times q of x times I of x dx plus c. Hmm. No, I of x plus c. Hmm. So yan, plus c. So, anyways, no, you substitute the values that you need. So y raised to 1 minus the n there is negative 3. 1 over the I of x that we calculated a while ago is x raised to 4 times the integral of our 1 minus negative 3 times our q of x, which we identified a while ago, which is 1 over x raised to 3 times our I of x, which is x raised to 4 times dx um, plus c. So yan. And then we simplify y raised to 1 minus negative 3 is 4 is equal to 1 over x raised to 4 times the quantity of, why do I keep using this one? Mm. So I have to enclose pa pala dito. And then the times the integral of 4 times 1 x raised to 3 times x raised to 4 dx plus c. Hmm. So yeah. So y raised to 4 is equal to 1 x raised to 4 times the integral of this one can be rewritten as 4x dx. Integral of 4x dx. And then um, plus c. Y raised to 4 is equal to 1 over x raised to 4. Let me get the integral of 4x dx, which would give you 4 integral of x dx is equal to 4 times x squared over 2, which would give you just equal to 2x squared. And then this one would be substituted here, 2x squared plus c. So yan. And then y raised to 4 is equal to, not forget to distribute. So it would be now 2x squared over x raised to 4 plus c over x raised to 4. And then we could still simplify this one. We would have y raised to 4 is equal to 2 over x squared plus c over x raised to 4. Or we could just have x raised to 4 as a denominator, but this is okay already. So this is the solution for the differential equation given in number 4. So I think that is all of the items that I give you. I hope so that you have understood the way we solve for the Bernoulli equation. So again, the Bernoulli equation is being used when we encounter linear first order differential equations that are not solvable using the way we solve for the linear first order. So we still have items here that you could work on. So you could use these items to practice at home on how to solve for the Bernoulli equation. And again, in the next meeting, we will have a quiz for the linear first order, this one for the Bernoulli equation, and then some of the applications for the first order differential equation, which is the ones that I discussed, which is Newton's law of cooling, and then exponential growth and decay, and then simple chemical conversion, and then half-life, which is part of exponential decay. So I'll be just giving an announcement to our GC what would be the coverage and how many items would be. Just prepare for the second quiz. And that is all for today. If we still have questions, you could just raise them on the GC. And then if I have time, I'll be able to entertain them. Bye.